Hi everyone, my name's Andy Robertshaw. Today I'm going to go through a greater than Killer Su Doku level 10 dated 31st of August 2025. This is number 30177, that's 30177. I particularly wanted to go through this one because it's got an interesting concept in it which I don't think I've been through before while going through these greater than puzzles. So it's a concept of the slack in inequalities. So I'll explain what that is when we get there, but I'm going to start this in my usual way. Look at cages with limited options. So I've got a 6 there, which is 1, 5 or 2, 4, and another there, 1, 5 or 2, 4. A 17 cage there, which is 8, 9. My 12 cage there could be 3, 9, 4, 8 or 5, 7. But I've got 8 and 9 in that column, and I can't have the 3 and 4 that would have gone with the 8 and 9 there. Shall we get into the concept of the slack now? I'll do one or two others. So the 5 there is 1, 4 or 2, 3. I'm going to point out one interesting thing. I've got this cage greater than this cage, greater than this cage, greater than this cage, equal to this cage. So I've got a string of 5 cages there, almost in descending order, apart from the last 2 which are equal. But that's going to be interesting later on. Let's talk about the slack now. So a 20, a 17 and a 6. We look at the first 2 columns. I've got 43 between those. And I've got 12 there, which makes it 55. So from 55, I've got maximum 8, and maximum 12. 55 plus 8, 63, plus another 8, 71, plus another 12 is 83. So having the very maximum in all of these to get me to 83, I've got a minimum of 7 in this one to make it up to 90. So it must be 7 or 8 and 1 or 2 to go with it. Okay, so maximum 83 there. I've either got to have a 7 there to give me a maximum, or where the slack comes in, if I've got an 8 there, I've got 1 slack. I can have one thing less than its maximum in one of these inequalities. But I know if I've got 7 or less here, this one must also be a maximum of 7. So I've already gone 2 down on the maximum. So I know this one must be an 8 straight away. So 1, 7, 2, 6 or 3, 5. This one, it could use the 1 slack. So it could be 7 or 8. But nothing more than 7 in there. Well, I've got 8 and 9 there anyway. But 7 or 8 in that one. What else do I know? Let's have a look at this box now. So if I've got 5, 7 in that 12 cage, so I must have 8 and 1 there. So this 6 cage must be 2 and 4. Right, but what have I got? So in fact, I've got maximum 12 there. Sorry, I'll come back to what I was saying in a second. So maximum 12 and 12 and 9. That's 33. In fact, I've got 32 or 33 because I know that's 11 or 12. So these two must be 12 or 13. So in fact, I know that's 4, 5 and that's 1, 2. And to make this 12 or 13, I've got to have 7, 8 or 9 in that cell. Okay, so let's go back to 5 and 7 there, 8 and 1 there, 9 there. I also know this is 4 and 2. Well, I don't care about the 2, but I've got 4 there. So 5, 7, 8, 1, 4, 9. I've got 2, 3, 6. So with 5, 7, I would have an 8 there. I'd have room for 1 slack, but I would have used it straight away there with the 2, 3, 6 I know I've got there. 4, 8, 7. So the 7 uses a slack in itself. I've got no slack left then. So 4, 8, 7, one less than the maximum. I must have a total of 12 there. But 7, 2, 1, 5. I don't care about the 1 again. 4, 8, 7, 2, 5, 9. I've got 1, 3, 6 there. That's 10. That's 2 less than the maximum. I can't do that, that's for sure. So I can certainly eliminate the 4 and the 8 there. If I've got 3, 9, what does that tell us? So 7 and 8 between those two. I cannot have a total of 6 there. The 6 partner for the 4, 5 goes in that cell. So I can have 1, 4 or 2, 5. So 3, 9, 7, 8, 2, 5 gives me 1, 4, 6. Or 3, 9, 7, 8, 1, 4 gives me 2, 5, 6. That's too much. So 3, 9, 8 and 7 that way round, and 1, 4 gives me 2, 5, 6 there, which is 13. So if I've got 3, 9, I must have 8, 1, 7, 4. 3, 9, 8, 1, 7, 4, which gives me 2, 4, 5. No, it won't give me that, will it? So 3, 9, 8, 1, 4, 7. That'll give me 2, 5, 6. Sorry, so 3, 9, 7, 2, 5, 8 will give me 1, 4, 6. In fact, that's impossible as well. If I've got 3, 9, 7, 2, 5, 8, I've got 1, 4, 6 less for this, which is 11. But I'd have an 8 there. If I've got an 8 there, I've got no slack at all. I'd have... I'm confusing myself here. I'm going to come back to where I am. I'm just going to pencil the numbers in for now. If I've got 3 and 9, that's what we're working with. If I've got 7, 2, I need a 5 there, and an 8 there, I would have 1, 4, 6. I'd have 1, 4 and 6 to go between those. But I've used 1 slack there with a 7, and I got 1, 4, 6. So I've got 7 and 11. That's 18, 30, and 43. That's 73. I'd need 17 there. I'd need at least 9 there. So that's not possible. So I can't have 3, 9, 7, 2. If I do 3, 9, 8, 1, so then that's a 2 and that's a 4. and that's going to be the 7, I'd have to have 2, 5, 6 there, which would break that inequality straight away. So basically, I can't have 3 and 9 anyway. It'd violate either my slackness or my inequality straight away. So I now know this 12 cage is 5 and 7 to give me 8 and 1 and 2 and 4. And this must be a 9. And the 2, 3, 6 that I mentioned earlier holds. That goes. Okay, so I've used the slack there. If I add everything up then, I've got 43 between those 6 cells and 12 and 8 and 11. So that's 74. So I've got 74 between those. I've got 16 left between those. Both less than 9 that I've got there. Sorry, I think I might have just been covering the microphone, so I apologise if that was a bit garbled. But 74 between those for 16 there. So both of those must be 8. I've got a 2 there. So I must have a 1, 3 and a 5, 7 between those 2 cages. So not 1 or 5 there. This 6 cage is 2 and 4. So not a 2 there. So in fact I can't have a 2 there because I've got a 2 in that box already. So between those I've got the other one of 8 and 9, and I must have a 6. But I can't have a 9, I've got a 9 in the column, so 6 and 8 there, and 9 and 8. So 1 and 3 there to go with that 6 or 8. So 3, 5, 7 to go between those, but not a 5 in the 10 cage. The 10 cage is 3 and 7. Let's have a look now at this 20 cage. I've got 5, 7 there and 5 or 7 there. So I've got 1 of 1, 3, 6, but not the 3 because I've got it there. So I've got 1 or 6 and 9. Not got a 9 in that column yet. And here again I've got 5, 7 there, 5, 7 there. Must have a 2 there, so 1 of 1, 3, 6, but again I've got 3 there. So 1 and 6 to go with a 4. 4's the number I haven't got in that column. Okay, so what else have I got? I can't have an 8 there. So the 8 in this box must be one of those 2. So that must be 8 and 1 to keep it less than 10. So not a 1 there. The 1 must be one of those 2. This 5 must therefore be 2 and 3. So I can eliminate 3 from there and 3 from there. So 10 is 7 and 3 that way round. Eliminate that 3. This one can't be 7. I've got 1 as one of those 2 and 2 and 3 there. So that's a 5 and 7 there. And again, not using 1, 2 or 3. The only number I could put with the 5 there is a 4. So not a 4 there. The 4 must be there in that box. On this top row then, I've got 5, 6, 9. And on this one, I've got 1, 4, 3. That's all I've got left to go there. Let's think now about parity. 18 is even. This plus this is even. They're both the same thing. So that's an even number. That plus that must be odd. So it must consist of an odd and an even number. So 4 must be the even number that's in one of those 2. So not a 4 there. Right. Let's fill in the rest of this row. So 6 or 9, along with 2 and 5. And this one, I've got a 1 there, but I've got 6 or 9, along with 7 and 8. So I must have 18 there. In fact, I can work out a bit more from these 2. They're either 1, 4 or 3, 4. So those two add up to 5 or 7. Paired with the 18, I've got 23 or 25. So I've got 20 or 22 between those. So each cage must be half of that. 10 or 11. Right, so that's interesting. So can't have a 6 there. So 3, 7, 3, 8, or 1, 9. But 10 or 11 is what I've got there. 10 or 11 is what I also must have here. So I suppose I could have 6 and 5 for the 11. 7. Can't have 10 or 11 with a 7 there. So no 7 there. 8, 2, or 9, 2. So I can't have 6 or 9 here. So 9, 2, 8, 2, or 6, 5 between those. Right, that's narrowed that down a bit. Let's now have a look at the transitivity of all this. So for knowing I've got 10 or 11 here, so that's at least 10. That's at least 11, one more than 10. That's at least 12, one more than 11. And that's at least 13, one more than 12. The only way I can have this being at least 13 is to put... In fact, I've got to have exactly 13 there, haven't I? 9 and 4, that's the most I can have, 13. So I've sandwiched myself to a 13 in that cage. So not 4 there, not 9 there. So I'm pretty sandwiched now between it. So max, that's 13. That's maximum 12, maximum 11, maximum 10. But I said earlier that's 10 or 11. So that's minimum 10 as well. So that's exactly 10. So it could be 1, 9 or 3, 7. This being 10, can't have the 5. So that's 2 and 8. So 2s and 8s can go from this one. So I now know 13, 12, 11, 10. So this must be 12. So it must be 5 and 7. So not 5 there, that's 6. That's 8 there. That's 6 there and 3 there. Right, so this being... That's a set of 3 cells that add up to 11. Okay, well, let's look at the row. So I've got 1, 2, 3, 5, 6. So my 11 could be 2, 3, 6. In fact, that's all it could be, isn't it? The only way I can have 11 out of those is 2, 3, 6. So the 1s and 5s must be those two between them. Not a 3 there because I've already got one in the box. Let's look at this box now. 27 and 10 is 37. So I must have 8 between this, this and this. So I can't have 2 there. I can't have 6 there, I beg your pardon. 6 there, I'd leave just 2 to go between those. Can't do that. So that's a 2. And there are 3 and 6 between them. So this and this is 6 between them. But it leaves... What does it leave to go in that column? 2, 8 and 9. Can't have both the 8 and 9 in the 16 cage. So can't have a 2... Must have the 2 there. But I can't have a 9 there. That's an 8 then. So 2, 9 and 5 and 1. And 5 there and not 5 there. So that must be a 4 to make it up to 21. This 27 cage, 4, 6, 8, 9. Not a 6 there, not a 9 there. What else we got? Let's have a look at this 18 now. So it could be 5, 6, 7. I can't have both the 6 and the 9 there because I'd need a 3 to go with them. So I do need the 5 there. And I need a total of 13 to go with them, so it is indeed 5, 6 and 7. That's the only way that works. So not a 6 there, not a 9 there, not a 7 there. So that's 1 and 9 and 3. Yeah, so now let's talk about deadly patterns. I mentioned deadly patterns. This is a more complicated one. But I'm going to show you that I want a 2 there using deadly patterns. So if I look at these two columns, what can I swap horizontally? I've got 5 and 7 in that 12 cage. Of these two 8 cages, one contains a 5, one contains a 7. So that's a 5, 7 deadly pattern, but I've also got 1 and 3 there. So I've got 1, 6 there. If I've got 3 and 6 there then, so I hope this makes sense. If I've got 3 and 6 there, I've got 3, 6, 1, 6, 1, 3. 1, 3 set in their rows according to, I could have 1, 3 both on the same row. I could have 1, 3 on opposite rows. But the fact that the 1 and the 3 are set in their rows will make it a deadly pattern. And similar for 5s and 7s. So if I swap my 5 and 7 there with my 5 and 7 in the same row, I'm not interacting with anything else. If I swap it with my 5 and 7 on opposite rows, I can keep the 5 and 7 well, if I end up having 5 and 7 on opposite rows there, in fact, I think I might just have been talking nonsense about that one. In fact, let's simplify it a bit. So I can't have a 5 there, can't have a 3 there. So I know my 5's on that row. In fact, I don't think I've got the deadly pattern yet, so I'll forget that for a second. I've got a 2 in that column, so 2 and 3 there. Let's take that one. So I don't know which way the 1 and 7 go round in that one, so let's just ignore that for now. I've got 4 there, so my 4's got to be one of those two. Let's fill in the rest of this. So 1, 2, 4, 7, 8, 9. But not a 2 in that row. Not a 7 in that column. Not a 1 in that column or a 9. Not 2, 4 or 8 in that one. I've got a total of 20 between these three to make the cage up to 45, but not 4 or 8 there, not 9 or 5 there. I've got 5 and 7 in that row as well in the 12 cage, and I've got a 4 in that row. I'm limiting my options here. I couldn't have a 3 there because I need 8 and 9 there. I've got an 8 in that column already, so that's 6 or 8. If I've got 6 there, I'd want 5 and 9. So 5, 9 there. If I've got 8, I could have 3, 9 either way. That's all I could have. So 5, 9 or 3, 9. So no 6s or 7s there. So I've got to have a 9 as one of those. So those two are 1 and 7 between them. Right, in fact, they don't form a deadly pattern with whichever one of those is a 1 and 7, because I've got an inequality and a cage which they're interacting with, so that's fine. So 1s and 7s spoken for in that box. Let's fill in the 5 of these. So 1, 3, 5, 6, 7, but not 5 or 7 there, not a 3 there. I've got a 1 in that row as well, so no 1s there. Let's fill in this column. So 1, 2, 4, 8, 9, but not 4, 8, 9 there. That's 1 or 2. Not 1 or 8 there. Right, so 3, 6. This is interesting. Remember, this is 8 with 3, 9 or 6 with 5, 9. So if I've got 3 and 6 that way round, I'd have to have an 8 there, but my 3, 9 option is gone. So I can't have 3, 6 that way round. So that must be a 6. That must be a 3. Right. So my 3 must be one of those in that column. My 6 must be in that column in that box. So 2, 4, 8. Right. What else can I do? Let's fill in. What else can I have here? 2, 4, 6, 7, 8. But not 4 or 8 there, not 8 there. So 1, 3, 5, 7. I've got 1 and 7. It's 3, 5 or 9 for that one. But not 9. It's 3 or 5 for that one. Yeah, the 9's got to be one of those two. Got a 4 in that row as well. So I've got an inequality here that I haven't yet looked at. So that cage must be at least 28. What I'm wondering now, the only place for a 9 in that cage is that one. Could I get away without a 9? So 3, 4, 5, 6, 7 is 25. So I certainly need an 8 if I've not got a 9 in there. Do I need a 7 as well? So 4, 5, 6, 7. I might get away without a 7, but anyway, let's have a look. In fact, could I? So if I've got 8 in that one, 8, 6, that's 14. If I've got, so I'm trying to work out, can I have a 1 there? 8, 6. 4 and 7's the most I could have there to go with the 1. So 8, 6, 4, 7, 1 is 26. So if I've got an 8 there, I want a 7 there. Did I say I wanted the 9 in that case? Right. No, I didn't say I need the 9, but I did need an 8 if I don't have the 9. That's what I said. But that seems okay. Right. Let's see what else. Now, I can't help looking at this cage, and I wonder if in fact, I have spotted something here. I can't have a 3 there. The 3 in this cage must be one of those. Sorry, the 3 in this box must be one of those two. So that eliminates any chance of a 3 there. So is that helpful? 6. Well, it's only relevant if I've got an 8 there. So 6, 5, 9, or 8, 9, 3. Okay, maybe not as helpful as I was first hoping. I can't have 5 or 7 there. Right, I've got a 1, 3, 6 triple there now, so not 1 or 6 in either of those two. So 5 and 7 of those two, that's not 5, so that's 9 and 3 and 8 to make the 20 up there. So let's eliminate those. So 1, 2, 4 triple there. So 6, 7 there and 5 there, and 7 and 5 and no 8s there. No 7 there either, so 4 and 2. So 4 and 2 gone. And I've got an 8 there, so that's going to be a 9 and an 8 there. Right, so I've got now 23. 4 plus 8 plus 9 plus 2 is 23. So that one is a 7. So not a 7 there, not a 1 there. Right, I've got an 8 in this row, so 9 and 4 there. Those two are going to be 6 and 8 between them. Not a 1 there, because I've got a 1 in the cage, so that's 6, 8, 6, and 3 and 1 there, and not 1 there, that's 8 and 1 there. I've got 1 there, so 2 there, 9, 2, 4, 1. I've got 2 and 3 there, so that's a 6. 3, 2, so 6 there and 7 there. Okay, so it's just these first two columns I've got to complete now. So 1 and 6, and so 1 and 7 must be that. Sorry, must not be that cage. It must be the other 8 cage. And 5 and 7 there. That completes the puzzle. Yeah, so I just hope it made sense earlier on what I said about the slacks in this column. So just a quick recap once again. I had 53 there, 43 there, 20 plus 17 plus 6, 43, and 12 makes that up to 55. So I had 35 to play around with between these two cages, this cage and this cell. But the most I could have were 8, 8 and 12. If I put the maximum in everything, 8, 8, 12, 8, I've got 36. I've only got one more than the 35 that I need. So I've only got one slack between this 8K, between this cell where I put the 8 and the inequalities. I've only got room for one thing to be one less than the maximum it could be. And that was a big help to the solution of this puzzle. So I hope that was helpful. I hope you enjoyed watching, and I'll see you on the next video.